Good morning.
Good morning. All right,
I like
today,
that smile. What are you working on today?
Today we're gonna disassemble the top end of this 302. It has really low compression, so once I get the heads off, we can CC the heads, and then we'll probably CC the pistons in the bore to see to figure out why it has such low compression. It has like 90 psi.
And it should have
It's like
what?
super low. It should have like at least 160.
And is it really a 302?
I don't know. We can check it. We
Dad
can.
says 327, but it's not.
I think he said
It's
302.
really a 800.
No. No. Yeah, we'll be able to figure that out also when we take the heads off.
Okay.
But the headers are welded to the exhaust underneath the car.
So, Andrew is in the process of eating.
Egos.
What is that?
And
French toast Eggo. It's bomb.
What'd you discover so far?
Oh, let me put this down.
just eat it.
All right.
You can use that as a pointer.
So, the intake
Yeah.
is the intake ports on the manifold are smaller than the intake ports on the cylinder heads. Another thing I found was the cylinder heads have a really bad design on the intake runner. So I can show you with my French toast down in there. So right here is basically, I guess you could say, pushed in because of the push rod, but it's not very smooth. Smooth transition or radius, whatever you want to call it. And then under here on the floor, it's really low, and it has a ramp that shoots straight up to the it's hard to see, but
To the throat of
to the valve guide, like right straight up into the top of the port. So
So the volumetric efficiency for this motor is probably like 40% because the heads are so large and the velocity is so slow that you really don't get any efficiency unless it's at 7,000 RPM. These heads are way too big for this current application the way it's configured now. That's why we had to put so much timing in. That's one of the reasons why we had to put so much timing in it. Another thing we found is, you know how like you see somebody wearing sandals that are like 4 or 5 sizes too small, and their feet are like hanging over the edge, right? Like in Walmart. So
In Walmart.
this valve guide here the valve guide roller tip is supposed to be centered on the actual tip of the valve stem. And the way they have the geometry, the push rod length is way too long, and it's pushing the I'll send an insert close up here, but the roller is way over. It's barely riding on the edge, which is really bad. And also we discovered, and this is just like so far, you know, this is only within the last couple hours, the valve guides are all lifting up. So that's a valve guide there. It's supposed to be seated onto the brass valve guide receiver grooves, and it's just floating up. So this one's like that one's like that.
What causes that?
Just poor quality. This is what happens when you buy Chinese heads.
Do you think they're coming up because the lift is too much?
I mean, it's possible that it smashed it, but I don't see any. I mean, without actually taking it apart.
Usually, isn't there like a retaining piece?
There's a wire that goes around it. But if the push rod guide seals are too large, or if it wasn't a proper fit, I've never seen them float up like that. I'm not saying that doesn't happen, but usually it doesn't happen on a well-engineered motor. But what happens is a lot of that oil will actually travel down the valve guide, especially on the intake side, and it'll start to burn oil. So this is just what we found so far. Another no-go is a plastic. See how that's leaking?
Yeah.
It's kind of loose. If these blow, then you can lose all your oil pressure, and then you can have engine problems. It's just leaking like crazy. There's like a bunch of like little small stuff. I mean, I should say small. They're all big stuff, but
All small stuff that adds to big.
yeah, it's just a bunch of things that are just either rushed or poor quality control.
And pretty much all the header bolts were almost stripped.
Really?
Yeah.
Like on the head or
On the head. On the head of the.
of the bolt?
Yeah.
Oh yeah, you know I see here. Yeah, just and usually you would use a 12-point on that to get good traction or good grip. But yeah, so that's what we found so far.
Are you guys gonna go deeper in? Or?
Yeah, we're going deeper.
Yeah, we gotta pull the heads off.
Deep dive. So we'll have to CC the heads, CC the chambers, and then, or I should say that the domes of the pistons. And this is why. So if this really is a 302, these heads are like big block status.
That was my first question. I said, how do we really know if it's 302?
Well, it feels like it's a 202. So.
No, it feels like a no 02.
I don't know. We'll find out when we pull the heads. We'll find out for sure if it's 302. If it is a 302, these heads are really big, especially with the compression ratio in the cam. So, anyways, like this is what we found so far.
Okay, so I was taking apart the heads. Or I was in the process of taking the heads off, and I don't know why, but I went to take a bolt out, and the washer was like stuck in the head, right? So I went to take it off, and I was like, what the heck? I realized
Why is that shorter than
that the head or the washer has a chamfer on it, because on the bottom of the head bolt, on the ARPs, they have a radius. So it's the chamfers are there to basically create space for them. And so these were backwards, and when they're backwards, it will cause uneven clamping force on the rod bolt, or the head bolts. And you can see this one's actually stuck on there. Can't get it off. Yeah, it's stuck. This one's probably stuck too, almost.
I was over there minding my own business.
This
working
one's
on my
stuck.
Chevelle.
Look.
And he's like, Dad, look at this.
Backwards.
Where's that push rod tip that was in the motor?
I gave it to you.
Somewhere.
You probably dropped
Actually, we'll insert it here.
Yeah,
it. You took picture?
Yeah.
Picture?
So, yeah, it was in the head, just
It was
chilling
right
by
there.
the lifter. Yeah, there you go. Right here. So that was in the motor.
Just sitting right behind the
Lifter?
the lifter.
So this is the tip of a push rod. This is one of the reasons why you don't use two-piece push rods in a performance application. You want these to be one piece forged.
Not only that, those are too long. So
And they're too long. Yeah. So.
You told me that about them being too long.
Yeah,
but look at this.
This is sad for the customer.
That was a nice learning experience. It's called tuition.
see if this one's back. Yep, backwards.
So
Almost stuck on there.
So if those bolts are...
So show me, so let's say I was going to build the motor. How would I know that that's backwards?
Because there's a chamfer on this side and none
not
on
on
this
that
side.
side.
And under here, under the head, there's a radius. So basically, it makes the head of the bolt stronger. And so it's supposed to sit like that.
I see.
See how that's flat?
Yeah.
This
But
way,
because it was put on backwards.
there's no chamfer on that side.
Right,
so when
so
you
then
put it on,
skips.
it doesn't sit fully on the head. It's hard at the head of the bolt, but it's hard to see. But there's a gap there. I could see it. But yeah, not good.
So what happens is the edge of that washer eats into the bottom side of the bolt, and it's what's called a stress riser. A stress riser is like a Sharpie test where they will nick a bolt and then they'll do a tensile test on it and see where it actually fails. Any stress riser is where a failure point can basically initiate, right? So if you cause a dent or a ding on the underside of the head of the bolt, that's where it's going to fail. Or the clamping load is not consistent, and then you have like a head gasket.
These two are stuck on there.
So they're all backwards.
They're all backwards, yeah.
All of them are backwards.
Whoever
huh?
put it together didn't obviously know what they were doing.
Yeah, whoever put them on.
Yeah, they just didn't know what they were doing.
Like,
They-
it's
so
not
they
like
were-
some were backwards, some aren't. Like, they were all backwards. So, whoever did that. This one's backwards, too. That one actually has a little bit of play in it, though.
The customer is already planning on rebuilding the top end.
Yeah. Hey Google.
So we need lifters,
Hey Google.
lifters, rods, everything. Honey? Not
What's that?
rods.
So I'm going to say that these heads are probably in the 76 cc range, just by how big they look. So we're gonna put 100 cc's. All right, so we're gonna fill it up to. All right, fill up.
Might have to just let it sit in there.
So tell me what you're doing.
So I'm gonna fill out the cavity to see what the size is, what the difference is.
It takes the whole thing almost.
So that is 25 minus 100 is 76, 75.
You're so special.
I learned to add when I was in the 8th grade.
8th grade.
Yeah. So yeah. So, like I said, there's 76, which is the biggest chamber small kit you can buy.
Okay.
75 cc, 76 cc's.
It's the smallest you could buy?
The biggest.
Oh, the biggest.
Yeah.
Okay, and what does that mean?
I
Good,
mean,
bad?
so
We're gonna
now we have
keep
to
that?
compare that volume size to what the dome is on the piston, which surprisingly there is a dome on the piston, so that's good. But we have to investigate everything to make sure that we know everything about this motor that we possibly can.
Right.
So there's a couple ways you can do it. It takes a little bit of math, but you could
Uh-oh.
you could lower the piston a predetermined height, like an inch down the bore, and then you take the volume of the bore that without the dome, right? And what it's supposed, you can calculate what it's supposed to be, right, empirically. And then, well, you take a theoretical, I should say, theoretical, and then you subtract, you fill it up with the CC tool, and then you subtract out what the dome volume is displacing, right? Okay. So you know what it's supposed to be, and then you fill it up with the fluid to see what it is.
Okay.
So these are actually stock style, like old school 302, like DZ 302 pistons.
Cast?
They're cast, yeah. They're not forged.
Is that good or bad?
Cast is worse.
Cast is not that good for performance. I mean, it'll work for this application.
Are these cast?
Yeah.
I was trying to hoping for one positive thing.
They're domed. That's positive.
Okay.
I'm working on it. That's positive. We left off trying to pour the IPA into the hole. But now that we have a better angle, we're starting with 100.
Under the sun. You took the whole thing?
Yep. So
Almost.
10 left.
So 90?
All right. This is what you call mission creep.
Mission creep?
Yeah. The initial intent was just to get it tuned, get the motor tuned, right? So, and one thing led to another. And
Another, and now look at the motor is like stripped.
Yeah, now the motor is down to basically a block. Because we keep finding things.
But MC2 makes sure that things are done right.
Nothing
Right?
leaves here that is not.
Either safe or 100%.
When it leaves here, it looks like this.
Right?
That's when it's done. All right. So yesterday we left off where we were CCing the cylinder number 6, and we needed to confirm what the dome size of the piston was, so we can check to see what the static compression ratio was supposed to be. So we moved the cylinder down and the piston down in the bore about ½ inch, and it's a 4.060 bore, so that ends up being about roughly 6 cubic inches. We convert that over to cc's. The theoretical volume, if you had a flat top piston, would be 6 cubic inches. However, because there's a dome, that displaces material. So we put the acrylic plate over the cylinder, and we filled it with we filled the vial with 100 cc's of isopropyl and filled the cylinder up. That yielded us 91 cc's. Is that what it was? 91 cc's?
Yeah,
Right, 91 cc's. So the theoretical volume of that cylinder at the flat top is 107-ish cc's. So that gives us about a 15 cc dome, right? So with a 15 cc dome and a 76 cc chamber head there, a combustion chamber, that yields us about just under 10-1. That's with the 40 thousandths head gasket with the piston 5 thousandths in the hole. So that's the theoretical, which is not, that's actually where you want it to be, 10-1.
Yeah.
So the problem is a lot deeper. I'm basically guessing that something with the cam timing is bleeding off all the cylinder pressure, because with a static compression ratio of 10-1, and with all those components, you should have more than 90 psi. So that means the cam timing is way off. It's bleeding off the cylinder pressure. So the static compression is just comparing the volume of the gas, or I should say, compressible gas at the bottom when the piston's at bottom dead center, compared to what it is when it's at top dead center. But that does not take into account camshaft timing. Camshaft timing, when the valve's open, when those valve events are happening, you have scavenging, and you have gas basically, being transferred from the exhaust from the intake to the exhaust and compressing. And when the motor's moving, you're trapping gas and everything's moving around, so you have to accommodate for speed and RPM. So the timing events will, that's why you hear a car like this will elope. It's because you have reversion where the timing, everything is kind of like it's not in sync. So it sounds like that, which sounds cool. Mm-hmm. But when you rev it up, it becomes kind of hard, like a symphony, and everything works well. So Andrew is going to take off the balancer and the timing cover, and then we're going to look at the cam, see what specs it has. So the cylinder heads, we CC'd them this morning, and they're 225 cc runners. Intake runners, right? 225. To put it in perspective, this car here is 408 cubic inches, and it makes north of 650 horsepower, and this has AFRs, 220cc runners, with all the appropriate material, or the material components, and it runs like this is a Symphony right here. Okay, this is properly built. The heads on that motor on a 302 are bigger than this one, and that's 408 cubic inches, and that's 302 cubic inches.
That's a harmonic balancer.
It's kind of a harmonic balancer. I think so. This impact is the best impact I've ever used.
Really?
It's bleeding off way too much, and it has, when we did the math, it's supposed to have about 10 to 1, I think. Either 10 or 10 and a half, I forgot what it said. But 10 to 1, and so, yeah. So I'm gonna take the cam out and see if I can get a part number on it, and see if I can find the specs. And the bolts for the timing chain, the timing gear, did not have Loctite, so, and they're Allens and a round head, so
They would
the
have come
tab,
loose.
the tab that has, you see these little tabs on this plate, those go over the head of the bolt, so it's like a safety thing, so it doesn't come out. So it didn't have either of those. All right, ready?
I've been ready.
Yeah.
I stay ready.
All right.
The moment of truth.
It's a boy.
Why can't it be a girl?
What do you think? Technically, the block's a girl.
The block is the girl? Nasty.
What do you mean?
What do you mean technically the block is the girl?
I said technically.
Because she just had a baby?
Sure. Okay, so the cam specs are intake duration at 50 is 236. Exhaust duration at 50 is 242. Let's see, the intake valve lift is 520. Exhaust valve lift is 540 on a 110 LSA. So,
Where's that again?
where's what again? What, this?
Yeah, what was that again?
What was it?
Yeah.
The specs?
Yeah, the intake duration.
236,
What did I say it was?
240.
240.
You're off. Very close.
242 on the exhaust.
What's the upside pressure angle?
110.
110. It's not that big a cam. No, you know, it's probably in there backwards. Not
What?
backwards, but like that still doesn't explain.
It's in there backwards.
No, not backwards. Sorry. You know, if you can get the cam 180 out.
Oh.
Right? All right. What's the
Okay.
diagnosis?
All right, so I took the cam out and I checked the part number so I could find the specs on it. And I also found the intake center line, and it's recommended to be 106 degrees, 106 degrees. So the cam was retarded 8 degrees, so we advanced it to 106 to where it's supposed to be. So
if it's retarded, you get more top end, but if it's advanced, you get more bottom end. Right?
Yep.
Right. So, and what made it worse is the heads are so huge, the air velocity going through them was like just so slow and sluggish that when the piston was going up and down, basically the airspeed could not keep up with the intake valve events.
Not only was it the fact that it was big, it was the design
Yeah,
of the port.
Yeah,
So
it's all the wrong combinations.
and don't buy Chinese heads.
Yeah, don't go cheap. Buy the good stuff. It'll save you a lot of heartache.
One and done.
Yeah, one and done. Buy once, cry once.
Yeah. Like and subscribe.
We
This
really
baby back
need
on the
you to
road,
like
right?
and subscribe. That helps us get more traction.